Hello.
Alrighty then, let's unmute everybody.
Thank you,
Hello,
Cobus.
everyone. Yes,
Hello.
we managed to realize that we had our mutes on this time for the intro video. We will at some point fix that and add some music, I believe. But welcome everybody to today's session of Dev Beard Ops. And just for those that are always curious, it's the beard on the inside that counts, not necessarily the one. Dark and I just happen to have one. And today we are going to be having a nice, fun chat with Will here. So, Will, why don't you introduce yourself to the folks watching us?
Sure. Hey, folks. I'm Willow Chandarina, a product manager with the Amazon Elastic File System team here at AWS.
Welcome, Will. Will, where do you join us from? You are.
I'm
I think we
outside
woke
of
you up.
Boston.
You're outside of Boston. So Will, this is very early morning for Will. So yeah, thank you, Will, for coming up this early on the show.
Happy
it's good to have you.
Not that early.
Yeah. Okay. Just to introduce myself for people who have not been here, my name is Darko. I do the same things as this gentleman here does as well. I'm a developer advocate. I'm based in Berlin, Germany. I get to yell at the camera and talk to you live on stream and on stage and all the kind of stuff that's happening in the last couple of years. So, Cobus.
Yes.
What do we do today? What do we talk about today?
Well, if we look at the bottom left, my show notes say using Amazon EFS. Right.
EFS.
Cool.
What is
EFS?
So
that's a great question. Let's kick that off. Will, give us the elevator pitch for what is EFS.
Sure. So Amazon EFS stands for Amazon Elastic File System, which explains a lot of what it is, but let's break it down a little bit. So let's start with file system. So this is a shared file system storage service that you can use from your AWS EC2 instances. You can use it from your containers. You can use it from your Lambdas, but you can access files from any application that understands how to open, close, read, write files. So it's great for any applications that you're writing now, that you're porting into AWS, that are used to having a directory full of files and accessing those files, and especially doing so in a way where multiple of these instances or containers or Lambdas share that same set of files. So it's think of it as kind of a cloud NAS drive.
So that's nice.
I think that's the best way for people to describe EFS, even though it might not be doing it justice. But in general,
so
it's
one of these basically, just in the cloud.
Put that down. We just went down for a second.
Yeah. Cobus is right now holding the production of EFS. Don't drop it. So yeah, in essence, I think the easiest way to describe EFS is a cloud-based network attached storage, and yeah, this is the question I used to get a while back when working with customers. Is like, so what's the difference between EFS, EBS, and S3, for example?
Yes.
How would you classify it in such a structure?
Sure. So let's do those one at a time. So compared to EBS, which is a block storage system that you attach to a single host, EFS is meant for sharing. So you would attach EFS to more hosts than EBS. The other property of EFS that I didn't get into yet is, by default, it is a regional file system, which means, so in the whole world of AWS availability zones, and there's multiple availability zones in a region, each storage we have can pick whether it's local to an availability zone or if it exists in an entire region. So by default, EFS is a regional file system, which means anytime you write data to your EFS file system, it is synchronously replicated to the other availability zones, and most importantly, available from all of those availability zones. Whereas EBS is something that is local to a single zone. So the short difference of why you might use EFS or EBS is you would use EFS if you need to share it, or if you need it to be available in multiple availability zones. And with containers and Lambdas and things, that gets to be a really interesting property.
So the most common use case, at least when EFS came out, was for me was I would have multiple EC2 instances, and if I want to share a common storage layer between all of them, EFS would be the solution. I mean, before EFS, I remember spinning up a NAS instance, and the NAS instance would have a bunch of EBS volumes, and then it's overhead,
Or
right?
just some fun rsync and service restart scripts.
Or there's this, what's it called? There's a plugin or a tool that uses S3 as a file system.
S3 Fuse.
Yeah.
S3 Fuse, yeah. It works, but I wouldn't advise against it. S3 is not a file system. S3 is an object storage. Hence, it's not something that should be used as such, at least not in the way, yeah.
And that leads into the second part of your question. So you asked, how do you compare it to S3?
S3, yeah.
You kind of just answered the question. So now we're getting into file storage versus object storage.
Correct.
Both of these are shared storage. So like if we're drawing our boxes of comparables like EBS not shared, EFS and S3 shared, but the interface that you use to talk to your storage is different in both of these. So with EFS, it's file, which means you're sitting at your command line and you want to open your file via VI, Emacs, whatever. You can just do it. You can modify your file. You can resave it, and that's all fine with stuff on EFS. Whereas with an object store like S3, it's all about downloading an object or getting your object, putting your object. So it's a different way to interact with your storage, which for existing applications or some of the tools and things you're trying to do on your systems may not lend itself directly.
I think the important thing here to understand about the difference here is like, see, there's a question from Songmyo about why is it called a file system. Is it's literally you mount it inside your container or Lambda function, and you can then access it as if it was a local file system file, like you would with any network attached storage of any kind. So the idea there is that, let's say you've got a config file that, let's take WordPress, for example, it's got that big config file that hosts everything. If you have that on one host, guess what? Host 2 can't see it. Mount it inside an EFS, or use EFS mounted and then create the file in there. All of a sudden you can mount it in multiple places, and now both instances can actually read and write to the file.
Correct. So it's literally a file system. So Songmyo, it's not object store. EFS is literally a network attached, or actually network attached storage, which is a file system level of access to files. So if you are writing an application that will use either EFS or S3 to access files, on EFS, your application just needs to be able to write your system level, OS level system calls to write and read files. If you want to write and read files on S3, you need to actually use the S3 API to do that. That's the big difference in this case. So cool.
And this means in a lot of cases, you can hide the fact you can hide the fact that you're using a shared file system to your application, because from the operating system level, you mount your file system into some path of your instance, and then tell your application that is your path. And as far as your application is concerned, those files are local.
Exactly. So your application doesn't know. I think. Okay. So a question now. When it came out, EFS did not support Windows. Does it support Windows now?
We do not support Windows. Well, we do not support a common protocol with most
Windows
hosts. So Windows likes to speak SMB.
SMB, yeah.
EFS does not speak SMB. We have another file system in the portfolio called FSX Windows that does a great job speaking SMB.
Correct.
EFS does not. If you do, however, have a way for your Windows host to speak NFS v4, we're happy to talk to it. It's just a little bit trickier to get that. It's possible. There are things called Windows subsystem for Linux and things like that allow you to load NFS drivers. A little trickier, but it works.
Correct.
Yeah.
And here's a great comment from Akram saying that EFS can be used by applications that share persist data, and this is basically how I envisioned it initially. And that's just a wonderful feature from EFS. So there you go.
Yep.
So let's dig into that then a little bit. It's like, what are the typical use cases for EFS, and how does that differ, I think, from Lambda and container workloads that people typically see?
Sure. So what I generally see is the use cases between instances or just VMs, regular traditional use cases, and containers are actually very similar, because the behavior is a lot of customers are containerizing their existing applications. And if they needed storage before, they need storage after. So some examples of that, Kobus, you mentioned WordPress. So content management systems are a very common use case for this, where you would use EFS to store your config files, your templates, your plugins, and even your images and other contents. What's nice about that is it allows you to build a auto-scaling content management system where the data is decoupled from the actual engine that's handling your requests. So if more requests come in, you can just add another WordPress with the same EFS backing, and it scales out pretty easily from there. And we actually have a lot of blogs on the website of how to set that up, both in containers and EC2 instances. Drupal and other content management systems, similar things.
One of the first things I've heard people use EFS for was actually WordPress, right? In order to scale WordPress across a cluster or multiple hosts, EFS is just a great thing for that. Now, I must jump in. My first experience with EFS was not good, and that's not because of EFS; it's because of my lack of knowledge. So one of the first things I worked on with EFS was working with a friend on one of his projects. It was they wanted to have this big old layer of things underneath, multiple hundreds of instances, and it was like hundreds of gigabytes of data. It took so long to copy the data to EFS because when EFS launched, the speed of writing and reading was dependent on how big the volume was, right? I think that has changed now. Currently, you can actually provision specific speeds. Back then, it was literally tied to the amount. And I know for me, it took so long to copy things on it. But I think that's no longer the case, especially now with the way you can provision, right? So tell us a bit more about the provisioning part of it.
Sure. Yeah. So we've done a lot in the area of performance over the last few years. So the first one that you're mentioning is the fact that so we have two performance modes. The one that we launched with and the one that you used here was called bursting mode, which means the throughput of your file system is directly proportional to the amount of data that you have stored, with the ability to burst to higher amounts for some amounts of time, based on like a leaky bucket bursting model. But we realized that wasn't appropriate for all use cases, particularly those that had a ratio of need to transfer more data than you have data stored. So we introduced something called provision throughput, which is if you don't like the throughput that we calculated for you, just tell us what you want. Give it to us via the API or CLI or GUI, and we will just give it to you right away. And then you can drive up to that amount, and you can change it every day as your needs change.
Yeah, and I guess the burstable model is great for cost optimization, especially if you don't need a lot of storage and performance is not an issue, but yeah.
Or if you just start storing a lot of data.
Fair point.
Once you start getting in like the terabyte range, you end up with a lot of throughput credit.
A lot of throughput.
Oh yeah, cool. Definitely. Just quickly, I just want to rerun the intro just for those folks that have joined us. I do see there was a bit of a spike now in the last 5 or 10 minutes. Today we are having a chat about using Amazon Elastic File System with Will from the team. And we're just talking about the various use cases of it and how folks are using it. And in terms of, I think we have touched on the idea of EFS being regional and also in different availability zones, and we talked about mounting the actual volume. Let's talk about how that actually happens, because not everyone might have done a network mount before.
Sure. Yeah. So the basic answer is we use a protocol under the hood called NFS, Network File System. Been around forever. We use one of the later versions of it. We use NFS version 4.1. For most people, it doesn't actually matter. You don't see what's happening. It's just the way it happens to work. But what you would do is, so let's just get started with an instance and a file system. So you would go to EFS, you would create a file system. You would create what we call mount targets, which are entry points to your file system from any availability zone you want to be in. So you would create one mount target per availability zone. In fact, what you're doing right here is you're using what we call the quick create, which will automatically create mount targets in all of your availability zones in the default subnet of each one. So you actually don't have to worry about it.
Oh, so if you want to get quickly started, this is it. So,
This is by far the best way to get started. And you can see here that you can have a regional or a one zone file system. The reason you might want, so regional obviously has the properties of it will have your data in all availability zones, both durable and available in all those availability zones. The reason you might want a one zone file system is to save some cost. If you have a dev workload or something like that running in a single availability zone, you don't need the data to be persisted anywhere else. You can save some money by clicking that button. But if you click create right here, you would have a regional file system, mount targets in all of your availability zones. And then the next thing that you would do is, let's take an EC2 instance. We can walk through all the different paths, but if you create an EC2 instance, actually, it would be, so click into your file system here, because we can give you, we have mount instructions.
There we go. Wait, let me find this.
There in the top right.
Attach. Awesome.
So you would log in, you would SSH into your instance, and you would just copy and paste that command right there, which tells it to mount that file system. So that's your file system ID. And the last piece of that command of EFS assumes that you have a directory called EFS somewhere in your local path. So you could you can modify that to /path to my file system or /my WordPress path or something like that. That's how you put your file system wherever you would want your application to come access that data.
Interesting. I love the fact that it actually uses it can do DNS resolution from within an EC2 instance, so you don't have to worry about it too much. Now, this is just mounting it once, so this is not writing it for persistent mounts. So if you're gonna run this, make sure to add the line, which is very similar to this one. It's not the exact same one, but make sure to add the line to /etc tab if you want to keep on reusing the same mount after you reboot, because this is just temporary.
You can actually, what you would want to add to FS tab is closer to the first command. So so if we're going to get into it, the difference between both of these is the first one assumes and uses what we call the EFS Mount Helper, which is a client-side utility that you can, if you're on a Amazon Linux instance, you can just do yum install EFS-utils and it'll get pulled down, and then you can use this command. The nice part about using this command is, well, there's several things. One is it's shorter, it's easier to type, and it dynamically looks up your file system ID via DNS, so you don't have to do the long thing. The other things that this allow you to do are, you see there it says -o TLS. This means that if you use that command, we will encrypt the connection between your local host and EFS. So it's got the nice security properties. You could also, instead of typing TLS or in addition to, type IAM, and you could use IAM authorization to authorize your access to your file system. So basically what we've done with the Mount Helper is we've added a lot of nice on top of the NFS protocol that allow us to do more cloud native things with your file system.
So that's what I love about these things. Tightly integrated services with AWS is that you get authentication kind of out of the box with a helper. So that's a really great thing, because I have a bunch of NASs here and I write passwords in my /etc tabs, which you should not do, right? So this is just a really great way. So I guess the suggested option is use the EFS helper. And is the EFS helper available on any OS, or can you have it running on any OS, any major OS?
You can have it running on any OS. So Amazon Linux is the easiest because we put it in the Amazon Linux repositories and just the yum install. We have instructions we have a GitHub page, and we have instructions on how to build for any OS that you want. If you are a user of SSM, AWS Systems Manager, it's available as a distributor package. So
That's excellent.
That can help you get it to any OS and have it automatically updated and things like that.
Cool. Well, basically, yeah, you provision a file system. Actually, provision a file system and what is it called? Mount points. Does this thing have mount points? Yes, it does. So it creates mount points for you. At least the wizard does.
Mount targets. So
Mount
if you
targets,
click
yes.
So click network down there and you can see them.
Yeah, in the network part. So, okay, gotcha. So these are mount targets.
Those are your mount targets, and they have IPs and stuff. But they all what we do a DNS trick, which says if you connect to the DNS name of your file system, we will resolve it to the local mount target wherever you are. So you don't have to worry about which availability zone am I in, which do I need to connect to, or if you're trying to standardize your scripts across hosts that run in different availability zones, you don't have to worry about localizing them.
That's a very cool thing. So I guess, it doesn't matter which AZ you're running your instances in, just the same mount script should do it. So
yeah,
pretty good. Like that. Now I seen something here. I seen access points.
Yes.
These seem like something that can be useful. Tell us what they are.
They're very useful.
Okay.
So like I mentioned earlier, one of the use cases for EFS is accessing from applications running in containers or running in or Lambda functions.
Okay.
Now, what's unique about containers and Lambda functions is when you connect these to a file system. Well, before we even get there, one of the ways that one of the things that happens whenever you connect anything to a file system is this concept of identity and permissions. So any of you that have used Linux before know that when you're in a Linux system, you have a user, you're acting as a user, that user has a user ID, you're in some number of groups, those groups have group IDs, and when you read and write files, your permission to access those files depends on your user ID and your group ID and that file's ownership ID and their mode bits. So like the RWX type mode bits. EFS works the same way, which means for EC2 instances, you can synchronize the privileges of your files across all of your different hosts and have a really good model of I am Will on this machine, and therefore I'm allowed to access this file, but Frank on this machine is not allowed to access that file, kind of thing.
Yeah.
When you move to containers and you move to Lambda, you no longer have user IDs that really work the same way because you're not synchronizing your containers to LDAP servers or anything like that. So the challenge that a lot of people face is, how do I still get the benefit of having permissions of who can access what files without having a central database of how those identities are synchronized? That is why we created access points. So with an access point, what we did is say, we know that the user ID of your application on the application side is completely arbitrary.
Yeah.
So in the case of containers, it was probably built into the container by somebody else, and you have no idea what it's going to be. It might be root. With Lambda, it's kind of abstracted away from you, and it just kind of picks something under the hood. Both of them are meaningless when it comes to EFS. So what we're going to do is assign the ID on the EFS side. So you create your access point and say, I want anyone that connects to this access point to inherit this user ID, this group ID, or these secondary group IDs. That way, it doesn't matter if the application thinks that it's root. If it comes through, it can pick up the user ID of 200, if that's what you configure here. So it allows you to have really tight control over what permissions your applications have when they come in, even if those applications don't really know the whole UID, GID construct. And the last thing it allows you to do, if you scroll down a little bit more, is root your application into something other than the root of the file system.
Gotcha. Yeah.
That's actually useful, especially for centrally managed like config folders. I know I've got one of my servers here at home, which is the main config for all of my service and containers and everything. So that's definitely super useful. Just want to check here the permission. I'm assuming then once we've got this access point, we then rely on IAM policies for the different containers and functions to whether or not they can access that access point.
Bingo. Yeah, exactly.
Okay.
So I guess there's kind of three things to keep in mind here. Here, you set up what's the identity of my thing coming in. That would be relative to how you set ownership on the actual files and directories inside your file system. But then, like you say, you want to make sure that the application that you created this access point for is able to A, assume it, and B, not assume any other access point that would give it different permissions. So to see how that works, we can go back into our file system and go into the, forget now what we call it, the tab.
Which one?
File system policy.
File system policy. There you go. Oh, okay. Interesting.
So here, if you click on edit, we've got a little builder.
Oh.
So here we can do cool things out of the box.
Oh, that's nice.
Like not allow people to connect via root.
Oh, I love that. I love this. I love this. I think more policy builders and editors should have like common policy options like this. I think this is just great. Enforcing the amazing.
Now we don't have a policy builder for what we're talking about, but I can walk you through the easiest way to do it. So go ahead and uncheck all those boxes just to have as basic a policy as
boom. Okay.
Now open up the grant additional permissions box.
Okay.
Oh, you can type if you want.
I don't. Okay. I was thinking. Okay, add.
Click add.
Okay.
There we go. So now what you can do is if you have a ARN for your IAM role, you can paste it in there. Oh, we're going to do it.
Let me try it. Why not? Hey.
Oh yeah.
We're doing it
demo.
live. Yeah. And to the audience, we've never done this before.
Yeah, but I must say, seeing this makes me super happy because I've been in a number of situations before joining AWS where it's useful giving folks access to the console and being able to provision their own infrastructure. But the amount of times people just did give full admin access to my one service and then they're able to break other services is not good.
Right.
Yeah, I mean, we actually had a container situation once where someone copied the template but didn't change the service name, and what ended up happening is similarly they didn't fix the IAM permissions, and this whole new service came up that didn't do anything yet, and the primary service went down. And we're like, how is that possible? That code doesn't even call anything yet. Like, it took us about 30 minutes to figure out, it's actually deploying over the original containers we deployed. So these kind of restrictions make your life a lot safer.
Let me just comment on one of the comments in chat. M17 Kia. It could be a bit sensitive, so let me know if it's too loud. But I think what you're picking up, the breathing, I was really close to the mic, and I actually had a sigh. So I'll try to mute myself, not to just. This is not an ASMR channel, by the way. So if you came here for AWS engineers breathing, it's not that. But this is actually cool. I love this, Will, and what Kobe says, like. I'm lazy, and I want to build things. But then you spend all the time building things. You like, I have an EFS stuff, built in, and it's all great, and it's gonna work. But then I have to write a policy that's gonna prevent a lot of people from accessing. I can't be bothered, right? Let me just give permissions for everybody, and I'm lazy, and I will just, give permissions to all services for this entire, just so, it's only for test. And that test kind of migrates to production. So having a very simple way to do this is just wonderful. So kudos to you, Will, and the team who built this.
Thank you.
All right. So now this, basically, we have added this. I used an EC2 role, right? Gave it read access. And what it did here is it added this principle here that has the ability to mount EFS volumes.
Yep. And the way, so if what you wanted to do is say only this role could access that file system, no one else could, the way you would need to do a little bit of surgery on the policy that we created, which is to remove the whole first item in that statement.
This one.
Yep.
Okay, yeah.
You just
Okay.
clip that out. Then
Right.
Yep. Now you're good. Now only that role can access your file system for read-only access.
Okay.
The next thing, and so we can also tie this to your access point. So that would be via the condition key.
Gotcha. So I have no access point, but I guess when you
Right.
create it.
Well,
You mean
you would have to go hunting for tags and values and stuff. So I'll just describe how you would do
Okay,
it.
yeah.
You would add a condition statement to your IAM policy to that line, and just say condition access point ARN equals whatever the ARN of the access point that you created.
Gotcha.
And then basically what it's saying is this role is allowed to connect to this file system, read only, but only if it's through this access point.
Wow. So I love the fact that it's easy, right? You can have all this flexibility and like assigning roles and giving them very clear permissions. Let me take you back to when Darko was a young lad of 19. I was managing
dangerous Darko.
Dangerous Darko. I was managing a Linux file share in a government institution back where I come from, and we used Samba for like file sharing. And I remember having this humongous config file that contained every entity and permissions for every entity. Like you would have to separate, individually define which entity has permissions to where. And I remember that was such a complicated thing for me. And it was not secure because it's a single config file and it could just be lost or corrupted or somebody can see it. So, but I like this. I like that you can do fine tune here.
It's not just that it's not secure, it's also something that I've hit a couple of times with my home server again, is that you make a typo in there, you reload the service. It's not like some shares work and some don't. It's either all work or either they don't, depending on the mistake you make. So you could potentially take down the network share for every single server.
Yeah, exactly. And as Alexander Gamerman says, everybody has both fixed and created problems with chmod 777.
Oh yeah.
my first years of Linux was basically chmod 777 everything. I didn't know how those things worked.
And then you figure out if that doesn't work, then just do chmod plus X, because that sometimes fixes your problem. And then like years later only I started reading like, oh, these things actually mean things. The numbers are bits and the bits have meanings. And okay. So
and here's a question, Will. What happens if I change file system permissions on the files on EFS? I have not tried it. If I do that, does that change it like normal, like on any NAS system?
Oh yeah, yeah.
Okay.
So every file in EFS has ownership. So it's owned by a user and a group, and it has the chmod bits. So it's your 777s or 755, whatever you happen to set, is what it is, and that is for anyone connecting. That those are shared permissions.
Gotcha. So remember, kids, chmod 777. Don't do that.
Yes.
Don't do that unless you really need to do that. Is there a reason for chmod 777? Like an actual? I don't know if there's like an actual need for a chmod 777, unless it's not even the TMP directory. I don't know.
It means you want anyone to be able to do anything on your
Exactly. Well, why would you ever do that? But okay.
Because you can't figure out the configs?
Yeah.
Cool. Let's talk about Lambda for a second, because it's kind of
that's one of the things I wanted to also cover as well. Just before we continue, another welcome to everybody joining. We see a lot of more folks joining the stream. Welcome. This is DevBeard Ops, the Wednesday edition. Every edition is the Wednesday edition, apparently. Today we get to talk to Will from the EFS team, or the Elastic File System team. We get to talk about the Elastic File Systems and all the wonderful things around it. We talked about what is EFS, how do you use it, and what are access points. And now Will is going to talk to us about how you can actually attach EFS or use EFS with Lambda functions and containers. Will, first of all, tell us why. Why would we do that?
Sure. So what we're seeing is there's a lot of people that are trying to build Lambda functions with what we've been calling, I'm looking for a better name, but we're calling reference data, which is some amount of data that would be super handy to be able to access from all of the concurrent invocations of your Lambda function. So the easiest example to think about is machine learning inference. So you have trained a machine learning model to recognize hot dogs and pictures. And now you want to deploy that machine learning model behind an API and make it so that you don't have to pay anything if no one is looking for hot dogs. But if the whole world starts looking for hot dogs, then it can instantly scale out as wide as it needs to handle all those API calls. So Lambda is a perfect execution mechanism for that. If only you could have those Lambda functions not only access a large model file, but also share that model file. So as you get better at recognizing hot dogs, you can load it in and then it can take effect on all your Lambda functions. So EFS turns out to be a really handy way of doing this. So the approach would be you write your inference logic in a Lambda function, you load your model file into EFS, you connect both of those to each other, and then as your Lambda function scales out and gets more concurrency, there's still just that one file in EFS that's shared that you can update, and it's instantly available to all of your functions.
I recall a colleague of mine, actually a friend of mine, he before EFS for Lambda was a thing, they were downloading files to Lambda functions, and Lambda functions are limited at 512 megabytes of storage. No, 512, yeah. And they would like download a file and process it, and it was like a whole thing, a lot of overhead. And I remember his question, like, "Hey, can you mount a network attached system to a Lambda function?" I don't see how you can do it unless you would do it somehow during the runtime, but that's not the ideal. Yeah, this is a great solution for that. And just the thing that you said, machine learning, right? Having a massive data set that's sitting on a network attached storage somewhere that can be just picked apart by Lambda functions on the same place and put back. I think that's a great thing.
Yeah. So that's probably the most common one we see. We've also seen people do things like build search engines.
Okay.
You have index files stored in EFS, and then as you want to put new things in, they get written and now they're available whether you have a search request come into the other function. So it's another similar kind of reference data type use case. We've also seen media processing type stuff come in where you want to use Lambda for transcoding or something like that, and you just want infinite storage sitting underneath to do that.
Okay. How does this work? How do you do this? How do I pseudo mount EFS to my Lambda function?
So it's actually pretty easy. When you're in the Lambda console, or you can do it from any of the Lambda interfaces, but the Lambda console is the easiest one. There is a configuration object called file systems, and under that configuration option, you can say, "Here is my file system. Here is so actually, before we get there, let's create a quick access point."
An access point. Okay, wait. So we need so that's the first thing. You need an access point.
Yes.
Access point. Create. Call it.
Now you're just selecting your file system. There we go. Now you call it.
AP. Okay.
So next, we're going to tell it a directory to go into. Pick something other than /. Because what's going to, so back to our change mod conversation. By default, file systems are not writable in their root path except from root.
Okay.
And we're not going to be running our Lambda function as root. We're going to give it a user. So instead of making it so that you have to create an EC2 instance to launch your file system to change mod your root so that your Lambda can write to it, which is really painful. We are going to have our access point create a directory for us with the permissions we want so that we can go straight from EFS console to Lambda console and not have to do any in between.
Okay.
So yeah, you can call it /EFS, you can call it devbeard, AP, whatever it happens.
I don't want to do devbeard off because /dev is something that I'm not sure if I can write into /dev. So
that's dangerous.
So this is the path inside your file system, not necessarily inside your instance or Lambda, but again, it doesn't matter too much.
Okay.
So for user ID and group ID, just you put don't leave it blank, but put something that, so put 1,000, 1,000. So basically it'll be the same as EC2 user.
Gotcha.
And then for root directory creation permissions, here's where we're doing our virtual change mod. So
Okay.
owner user ID, make that 1,000 because we want to own our own data.
And
Group ID 1,000.
1,000.
And then here we can make our permissions 755. We can even make it 700.
Okay.
So 770
read only.
means anyone can do it. 700 means
Read
I'm
only.
1,000. It's owned by 1,000, so I can do whatever I want, but no one else can.
Which is a fair point.
And now
Okay.
click escape.
Okay.
Now
It takes a
we're
moment
ready
for it,
Lambda.
right? Okay. Good. Let's do Lambda. Lambda. I'll create a silly Lambda function. I think I just want to show how it looks. Hello world. Because of course. Gonna call it dev beard ops EFS. Create a new role. Do we have to something with roles in this case? Do we have to do something very specific, or is it like a default role should be fine?
Well, you did put a file system policy on your file system.
Okay.
So we're going to
I did a specific.
Yeah, so we can go one of two ways with it. One is we can let this create a role for us and then add that role to your file system.
Okay. Let's do that.
Or the other way around.
Let's do that. Okay, creating this. There's a question from your WFG. Where is that documented with the string values? Your WFG. What exactly?
That came in when we were talking about the access points. I'm assuming the different config options around the access point.
Okay.
We have a doc page on working with EFS access points. Let me.
Yeah, I've got it. I'll paste it quickly. Cool.
Cobus.
Here we go.
Boom.
Yep.
There we go.
Okay. Right. So we have a dummy Lambda function here. Before we continue, we need to add the permissions, right, to the EFS policy, right?
Right.
To the file system policy. Let's edit. Now, let me actually. You know what? The easiest way would be.
Yeah, just swap out the role.
Console, and then there's a role. What is a role? I can just copy this one. No, that's the function error.
I don't think you've attached one yet.
It should have an attached one because I created one during the.
So click configuration. I think
configuration
you in there.
There's the role. Okay.
Okay.
Here's the role. Role arn. Here. Here, and then just change this thing. That. Boom.
Yep.
Save. Gotcha. Okay, so we've modified this principle to be the role that we have just created along with the Lambda function. And now, tell us what we do.
So now, scroll down in your. So there, another prerequisite is you need your Lambda to be in your VPC. So if you.
Well, that makes sense.
Yep, because that's how it connects to the file system. So just
because
the default VPC. Nope.
I think this is the default one. Yeah.
There.
So.
And then for subnets, click all your default subnets. You can do all three. There we go. Now security groups, choose your default security group. That's the one that we attach to. So if you attach this to it as well, then they'll be able to talk to each other.
Okay.
There it is.
Okay. Save.
Oh no.
The products. See. Okay. So the Lambda function needs different permissions than this. Okay.
Well, it means you need to.
Yeah.
Since
Me as my user.
Your user role that you're doing this on needs access to. Because
My user role is an administrator.
Arca, you've been locked out of your account.
I've been locked out of my account. I apologize. So let me try again. Default. Save. the provided execution role does not have permission to create network interface.
Oh, no. So Darko, that is your IAM policy for your Lambda function.
Exactly.
It doesn't have that right, because remember, inside the VPC, it needs an ENI upon creation for the networking.
Correct. Okay, so
yeah.
Then let's
Oh, he's going to make it admin, isn't he? Let's watch.
No. Don't look. I guess EC2 full access. I don't know. Attach policy. Don't do this at home, please. Okay. VPC default subnet 123, and then a security group should be the default. And solve it. And boom. Okay. So see, chmod 777 solves the.
Yes.
Don't do this.
Please just give me access to this Lambda function. I'll show you how to start deleting infrastructure. It's gonna be so much fun. Yeah.
Okay. So now, file system, right?
You got it. Yep.
Wait, it's updating the function. It's doing something. Oh, because it's in a. Okay. It takes a moment, I guess, for it to update or something. To be placed in a security group.
It's setting up some network stuff on the back end.
Yeah.
Okay. While that is happening, maybe we can address the question, Scobus.
Yes. Okay. So first question from my side is actually, when you do this with a Lambda function, obviously it does all the network provisioning now upfront upon creation. Is there any other impact in terms of the Lambda function, or is it just like Lambda fires up and there's the file system that we need to worry about?
That's pretty much it. So all of the connection from your Lambda function to EFS is handled on the back end. You never see it. What you'll see is when we configure it, the only thing that your function code itself has to worry about is what path did you mount it into, because that's the path that you're reading, writing files from. And for some people ask, like, what if my function scales out a whole lot? Am I going to hit some limit of how many connections I can have to my file system or something like that? The answer is, unless you're going super, super, super crazy, no. We support up to 25,000 concurrent connections to your file system, which is well above the default limit of concurrency for Lambda functions. So it'll be fine.
Yeah, and that also, I mean, if you're hitting that kind of level of concurrency, you probably have a different architecture requirement than a mounted file system. Yeah. Let's quickly look at the questions that we've had in the meantime in here. I just need to scroll up here quickly. Here's the interesting one, which is, how does the mounting work with the limits of AWS Lambda with regards to the layer on container images?
So I guess one way of answering is to say that EFS operates outside of those limits. So there are lots of different storage and container kind of limits for your Lambda function. One of the reasons why customers connect EFS to their functions is to give extra space where one of those limits did not allow. So for instance, if you need to have more temp data than the 512 megabytes temp space allows you to do, then you can use it for that. If your code bundle, so if you're pulling in tons and tons of dependencies and it goes over whatever the default Lambda function space limit is, but I forget what it is these days. What some customers have done is they put some of their libraries on EFS, and then at init time, they pull those into their function so that they can have more code space. Although it's less common these days now that you can package container images up to 10 gigabytes and send those into Lambda, but maybe still.
Yeah, that's the extra file space is definitely a useful one. I actually spoke to a customer who was busy building a Lambda system on top of an Oracle database, which is an odd combination. And the challenge there for him was that the driver files to interact with the Oracle database was, I want to say, 240 megs or something like that, just for the driver, without anything else. And he also ran into the issue of like limits and not being able to get everything into the Lambda function, and had to do some funky things to try and access it.
Interesting.
Okay, I think we're ready to attach the file system.
we good to go, Rocco?
This Lambda function has stabilized. It's now in a VPC. Now we have to go just to the file system here on the bottom, right?
That's right.
Add file system. EFS, this one.
Yep. Got nice drop-down boxes here.
Access point, okay. And the local mount point.
Yep. So you have to start with /mnt.
Oh, you have to do it.
And
okay.
then you can type whatever you want after that.
That beard ops. And then solve it. And that's it, right? Now, technically, my Lambda function can read and write to that file. Well, actually, it can read and write. It's 700. Right? So it can read and write to that file system, correct?
Yeah, exactly. As long as you're doing so from within that path. So still, if you do stuff from /temp, you're still reading and writing from temp space. But now you switch, if you were to do like a open os.open /mount /devbeardops /my file, then
I think it's like import fs and then os, right?
Yep.
OS, and then there's something os.read, right? I forgot. I don't know Python by heart, but it's basically you can read from a specific path, mnt dev beard ops. Now in the access point we put a path EFS. Does that play a part here?
It does not. So that's a common misperception here. So the way to think about it is there is a hierarchy of directories within your file system, and then there's a hierarchy of directories on your Lambda, your EC2 instance, or whatever. So what you are trying to do is figure out where does this level of the hierarchy map to this level of the hierarchy.
Okay.
So when we said we wanted our access point to be /EFS, we said anyone that connects to that is going to connect one level up on our file system here. So what you see as root in your file system, or at least the root of that directory, is actually going to be /EFS on the file system side.
Okay. So before we move on, there's a question from Karthik Kayan. Well, there's no question. Karthik, ask us a question. Feel free if you have a doubt on this topic. We would be happy to answer if we can. So take it away.
But while we wait for the question to come in, so on the previous topic, that actually is quite a nice feature there, because then on your main EFS volume, and I can't use my hands because my arm boom is in the way, you can actually have like subdirectories inside the single EFS volume for, let's say, WordPress 1, WordPress 2, WordPress 3, and then create the access points to just map to those ones. And if you've got some, let's say, overarching admin interface, you can actually then mount all of those or mount the root and actually give them access depending on how you do your directory structure, and then access everything in one go as well, which is super useful.
Yeah,
that's
so
amazing.
It makes it, and it's very common to share a file system among multiple applications. And doing it this way allows you to give each application their own private view. They can't access, or even they don't even know that they're sharing a file system with other applications. Yeah. This is actually how, and we're going to a somewhat different thing now. This is how we built our driver for Kubernetes. So when you attach your file system to an EKS cluster, what we're going to do on the back end is, with dynamic provisioning, every time you deploy a application, or every time you create what's called a persistent volume claim, we're going to create an access point on your behalf that is private, and then attach that to your pod. And if you ask for another one, we create another access point on that same file system, and we do that sort of sharing behind the scenes for you, and it just makes it really easy to manage.
I like that. I like the fact that, like, for example, here you can see root directory path is EFS. Now, we can have as many access points on a single file system as we want. I guess there's a limit.
You have 120.
120 access points per file system. Basically, each of those access points can point to a specific location in a file system, and these permissions are set to that. So you cannot go beyond them. If you're attaching a file system through the access point, you can only attach it in this path. So that's pretty powerful, I must say. So cool. Question from Karma Islal. Karma is lol. JSON versus YAML, please. Oh boy. So both are markup languages. Are they? No. JSON is object notation.
Yes.
So
Well, both can contain information, but when you
Yeah.
refer to server configuration, we need a little bit more info than that, because you could argue that Chef uses JSON objects, so you can use that as a mechanism to configure a server. Ansible uses YAML for their base, like roles he execute and things. So I think we need a little bit more info on the question in terms of where do you want to configure the server and how. Or are you referring to JSON as part of the cloud init that you can run?
you can. So if we're talking CloudFormation, you can use both JSON and YAML to build CloudFormation.
Not CloudFormation, Cloud init as part of the
Cloud init.
EC2 instance lifecycle when it starts up.
Yeah. Okay. Okay. Cool. But
Yeah. So let's see quickly. Here we go.
Carthy.
Yes.
I've created a workspace and installed Chrome, Zoom, and Microsoft Teams. I created an image on that workspace, then created another workspace using the image bundle. Okay. We're waiting for the rest of the questions. Carthy, let us know.
Cool.
Math hack. This is a question regarding EFS. How to spin all of this with CDK? Is there a CDK/CloudFormation support available for all of this? Well,
there is. So CDK, I forget what the exact terminology is, but CDK wraps any CloudFormation object. So you can basically do any CloudFormation thing from within your CDK scripts.
Yeah.
There are also the helper functions that do some automation behind the scenes. EFS does both. So the file system object, the access point object, the mount target object, all of those can be accessed directly in CDK via the low-level interface. There is a high-level interface for creating a file system that automatically creates mount targets and things like that. I believe it's still technically experimental, but it's not that complicated. So you can use it. And what you would do then is you could have a CDK that creates your file system, creates your access points and your mount targets and things like that, and then just passes those references into whatever's launching your container or your Lambda function.
So if you want to read more, I just pasted the link to the CDK documentation for EFS. You can see, depending on which language you want to do, the CDK code in there. And we are now on 57 minutes and let me see if I can check on the watch. Actually, almost 58 minutes. So we have to start wrapping up because we have got a tight schedule where we have to end on the hour. And I want to take the last few moments to say thank you, Will, for coming to chat with us today. This was super useful. I knew about EFS in having used it a little bit, but there's definitely a lot here to unpack, and I'm going to go play some more with it now.
I've learned more today. I've learned more. I'm particularly excited about the access point things. I think those are really powerful. And were the access points here from the start or no? I would say no.
They were not. We launched them about the same time that we started launching integrations with ECS, EKS, Lambda, because we saw the container and serverless kind of need come up.
And I think my first interaction, the EFS DNS mounting, that was also not there with launch, if I remember correctly.
Correct. Yeah, the regional DNS were not there at launch. And just one quick thing that we launched recently is, so some customers try to do cross VPC mounts, so they'll peer two VPCs and try to mount across them. And whenever you peer VPCs, not all the DNS names make it across, including ours. The Mount Helper that we mentioned earlier now has the ability to, if DNS doesn't resolve, it'll start making IAM calls on your behalf so it'll describe file systems, describe mount targets, and it'll just go looking for other ways of resolving your file system across the VPCs so that you don't have to back off to like mounting via IP.
That's very cool.
Oh wow, that is super useful. Yeah. And so with the last 20 seconds that we have got left, sorry, I have to be the timekeeper today. Thank you everyone for joining us, and we will be back next Wednesday. Actually, no, we will not be back next Wednesday because it is a public holiday for me here in South Africa. So I will not be streaming. I will be at the beach.
Yeah. So basically, Next week we're off. The week after, join us here as well. Feel free to reach out to us on social media if you have suggestions, questions. If we didn't get a chance to answer a question now, please reach out to Cobus and myself on social media. And Will, once again, thank you very much for joining us. It's a pleasure having you here.
It was a lot of fun. Thanks
Awesome.
a lot for having me.
See ya. Bye.
Adios, folks.